Hey guys, it's Miss Damaso. Today we're going to get started on our new chapter. We're going to be starting on our chapter 10 today, which is all about circles. So this is our week 4 video 1 notes. Remember, you can follow along with my notes if you go to Edmodo. If you have a printer at home, you can print them out and follow along with me. Otherwise, it would be smart to just write your notes on a sheet of paper. So we're going to start off just by talking about some different vocabulary words about circles. So we're going to go through the terms, their definitions, and then we're going to draw ourselves an example or a picture of each one of those. So the first word is obviously circle. Circle is the set of points equidistant from a given point, the center. Equidistant means all of the distances are equal. They're exactly the same. So a picture of a circle, you're always going to have the circle. You're going to have a point in the center, and that center point's always going to be labeled for you. So if I put whatever letter I put here, that's the name of my circle. So since I put the letter P here, this is called circle P. So it's always based on the center point. You may also see it drawn as a symbol that looks like this. It's got a dot and the circle, and then we put the P. Okay, so that is our drawing of a circle, or our symbol for it. Second one is the radius. Radius is a segment with endpoints at the center and on the circle. So your radius has to be at the center, one of the endpoints of this segment. The other point can be anywhere on this circle. So it can be up top, it can be on the side, it can be diagonal. It doesn't matter where it is. And then you're going to have your circle point always labeled, and whatever that point is would also be labeled as well. So the radius in this point is segment AP. Another radius could be if I put another point here and go to the center, as long as it's on the edge and goes to the center. My third word is chord. Chord is a segment with endpoints on the circle. So it doesn't go through the center. They're just 2 points that are somewhere on the circle. And they can be anywhere as long as they're on the circle. Okay, so I've got my 2 points somewhere on the circle. They do not go through the center. So you can have a chord that goes this way. You can have a chord that goes up and down. Left to right. It doesn't really matter as long as you've got 2 points on the circle. A diameter should be a word that we know. Diameter is a chord that passes through the center. So this diameter has to go through the center point. So if my center point here is P, the diameter has to go from one end of the circle through the point to another end of the circle. Now, we know this whole thing is the diameter. It cuts it in half, cuts my circle in half, right? If I just did one part of this, that would be a radius. So 2 radiuses, or radii is what we call them, 2 radii put together give me a full diameter. Those are some words I'm sure you remember. Next word is a secant. Secant is a line that intersects the circle in 2 places. Okay, so it's some kind of line, and it's going to pass through this circle at 2 different points. So I can pick 2 different points. Let's call it X and Y. And it's a line that goes through those 2 points. And a line means that it goes on forever and ever in both directions. So a secant doesn't end at the circle, it goes beyond the circle. Move my paper here a little bit. Okay. Next one is a tangent. Tangent is a line that intersects the circle at exactly 1 place. So it's very similar to a secant, but instead of it going through 2 places, it's only going to go through 1 place. So maybe it goes through this point all the way up here on the top. But of course, we have 2 other points that are somewhere else on the circle. P, we'll put an R here, right? Because if it's a line, you need at least 2 points so that you can name that line, right? So it only goes through it at 1 point and nowhere else. That would be called a tangent. Last one's called the point of tangency, and it's the point where the tangent line intersects the circle. So if I'm looking at this picture here, the point of tangent C is this point Q. All right, so it's where my point, it's the name of the point that intersects my circle. Easy peasy. Okay, a couple more definitions. Next word is called central angle. Central angle is an angle with a vertex at the center and two sides that are radii. Okay, so that means I've got my center point, P. It's an angle that has a vertex at the center, so that's my center point, and two sides are radii. That means one side goes to one edge of the circle, the other side goes to the other edge of the circle. And I can name these points A and B, and what you should see is you have an angle right here. You have angle APB. Okay, it's an angle that we've seen before, it's just now it's on a circle. And it's called central angle because obviously the point is at the center. Easy way to remember that. Next word is inscribed angle. An inscribed angle is an angle with a vertex on the circle and two sides that are chords. Okay, so the vertex is somewhere on the circle. I'll call this point C here. The other two sides are chords. Chord just means, right, it goes from one edge of the circle to another edge of the circle. So maybe I have a point here and a point here. And so a chord means you're just connecting those two endpoints, and it does not go through the center is what you should notice, right? So the central angle went to the center. An inscribed angle does not, but it's inside of the circle. So this angle right here is angle ACB. Okay, and that is an inscribed angle. Okay, my next words are called arcs. And if you think about an arc is something that's like, it looks like it's curved, right? So an arc is a portion of the edge of the circle defined by two endpoints. So an arc is a piece of the edge of the circle. So for example, if I have my point A and my point B right here, the arc would be the line that connects A to B that's on the edge of the circle. So it's actually, right, a curved piece. So the symbol looks like this. So I would call this one arc AB, and I'd put a little arc right on top of it to show that it's an arc. Now there's two different types of arcs. One's called a minor, one's called a major. As I'm sure you can probably figure out, minor means an arc that has a measure that's less than 180 degrees. So it's like an acute angle. It's something small. We use two letters to name a minor arc. So for example, if I have 3 points on the circle here, A, B, and C, the minor arc would be this small piece from A to B. Right? And that is definitely less than 180. 180 would be a straight line across, but this is just one little piece. So this is called arc AB. And we use two letters when it's a minor arc. The next kind of arc is called a major arc. A major arc is just an arc that measures greater than 180 degrees, so it's bigger. It's like a obtuse angle. We use 3 letters to name it because it's bigger. So again, if I draw this same picture here, oops, A, B, C. The major arc is not this small piece from A to B. The major arc is if I go the other way. I go from A through C all the way to B. right? And you can see how that's much bigger. Now when I name that, I name it in the order that I go. So I started at A, I went through C, and I ended at B. So I'm going to call this arc A, C, B. And it's a major arc, and I put the arc symbol on top of it. All right, last word, semicircle. Semicircle is an arc with endpoints on the diameter. It always equals 180 degrees. So a semicircle should look like, remember we just did spheres and hemispheres. Hemisphere was half of it. A semicircle is half of the circle. Okay, so I'm going to put my 2 points. I'm going to call this J, K, and L. Okay, the center point is point P. Remember, a diameter has to go through the center. So this arc right here, J, K, L, is half of the circle. And it's pretty easy to see that it's half of the circle, right? It's got the diameter, it's half of it. So this is called arc J, K, L. I could also name this arc L, K, J. Right? It doesn't matter which one comes first, but what does matter is that the K is in the center because it's going through that point. Now, last part are some formulas that we need to make sure we remember. Area of a circle. Hopefully you remember that. Area of a circle is just pi r squared. The r is my radius. Okay, that one's easy. We remember that one. Circumference is, right, the distance that I have to travel to go around the entire circle is circumference. So my circumference is, the equation is 2 pi r, where r is the radius. That is one choice. You can also use, if you don't want to use that one, you can use circumference equals pi d, where d is the diameter. Now, these two equations are exactly the same because 2 of the radiuses, right, 2 times the radius gives me the diameter. 1 diameter is 2 radiuses. These two are the exact same equation. You can use either one. Last equation is arc length. So if I wanted to find the length of this arc right here, JKL, here's how I'd have to do it. I take L to be my arc length, and my arc length is X times C over 360. Now, the X is my degree of the arc. So if I tell you that the arc, this arc right here is 180 degrees, you would plug in 180 degrees right here. The C is my circumference. Okay, so for C, I could either plug in 2 pi r, or I can plug in pi times d. Either one of those is fine. And then I divide it by 360 because a circle is 360 degrees. Okay, now we have talked just a little bit about just some regular vocabulary words that are going to help us out. Now we're going to actually get ourselves started on our notes themselves. So these notes are going to talk all about central angles and arc measures. So remember, we'll go back really quickly. A central angle is an angle that has a vertex at the center and 2 sides are radii. So it's going to go into the center, out from the center, and I'm always going to have a radius and a radius. Excuse me. Okay. First part, central angles and arc measures. All right, a central angle is an angle with its vertex at the center, right? Hence why it's called a central angle. So it's at the center of the circle, and its 2 sides are this piece and this piece. Those are the radiuses, or the radii is how we say it with multiple. That means more than one radius, okay? So for example, this angle right here is a central angle in circle B. So circle B, right, this is the center point. The angle right here is angle ABC. So this little piece right here is 84 degrees. The sum of all central angles in a circle, so if I were to add up this angle plus this whole big angle out here, I'm always going to get 360 degrees. The measure of the arc formed by the endpoints of a central angle is equal to the degree of the central angle. So here's what that means. That means this small little piece right here on the inside is 84 degrees. That means if this angle right here is 84 degrees, its matching arc on the outside is also 84 degrees. So the measure of arc AC is 84 degrees. That's a minor arc. It should be less than 180. The other one is arc ADC. That means you start at A, you go through D, and end at C. Now that's really easy to see that that's definitely a major arc. It's bigger than 180. And to find this angle right here, I'm going to take the whole thing, 360, and I'm going to subtract this blue piece from it. And that will give me what's left over as the pink. So I'm going to do 360 minus 84. And if I do that, I get 276 degrees. So this major arc out here is 276 degrees. This angle in here is also 276 degrees. All right. Now, we're going to do some example problems. So for each one, we're going to find angle and arc measures for each one of these. Now I'm going to have a lot of colors just so you are aware, just to kind of help us show some different pieces. Okay, so the first thing I see is that this angle right here, SQT, is 122 degrees. Well, if this piece right here is 122 degrees, guess what? That means this arc right out here, its matching arc, is also 122 degrees. And look at that, that happens to be my first question. It asks me, what is the measure of arc ST? That's this distance right here. It's 122 degrees. And look at that, I already did the first one. Okay, next one it asks me to find is the measure of arc RS. So here's RS. It's this little piece right here. Now, what I notice is that if I were to put this yellow piece and this green piece together, I end up getting half of the circle. Well, half of the circle is 180 degrees, right? It's a straight line. And then, right, if this is 180, that means this piece is 180 over here. Okay, because when I add them both together, I get 360. So I know this piece in yellow plus this green piece is 180. So to find just the green piece, I am going to take 180 and subtract 122. If I do that, I get 58 degrees. So this angle out here, this arc, is 58 degrees. Last one it asks me to find is the measure of arc SRT. Now there's 3 letters here, which means it's a major arc, so it should be greater than 180 degrees. So SRT means I go from S through R all the way over here to T. That's this pink piece here, okay? So the pink is everything except for what's left over here in the yellow. So in order to find that, here's what I can do. I can say I know the whole thing is 360. If I take away this yellow piece, that will give me what's left over. So in order to do that, I'm going to do 360 minus 122. When I do that, I get 238 degrees. So I know this arc, woo, wrote the wrong thing. 238 degrees. That is one way you could have done it. You also could have done this. I know this piece is 180 over here, this top half. That must mean this bottom half right here, R to T, is also 180 degrees. If I wanted to find the whole distance of this pink piece, I could do this 180 plus the green piece is 58. And guess what? If you do that, you get the exact same answer. So you can either add arcs together or you can subtract arcs as well from the total 360, and you're still going to end up getting the exact same answer. So that's pretty cool. All right, number 2. First thing I see is that this angle right here is 21 degrees. Knowing that this small angle is 21 degrees, that must mean that this arc out here, J to K, is also 21 degrees. So I'm going to write that in. Oh, look at that. That's the very first thing it asks me for, the measure of arc JK. It's 21 degrees. Okay, now, I know these two angles right here are directly across from each other. These are called vertical angles. What do we know about vertical angles? We know that vertical angles are congruent. So if this angle, this arc is 21 degrees and this angle is 21 degrees, well, guess what? That means this angle is 21 and this arc is also 21 degrees. Okay. The next number it asks me for is, it says find the measure of angle JNM. JNM. So I want to know what this piece right here in green is. Well, I know that if I put this green piece together with this yellow piece right here, I have a diameter. So I end up making half of a I end up making half of a circle, which is a semicircle, which is 180 degrees. So in order to find this angle right here, I'm going to take 180 and I'm going to subtract 21. When I do that, I get 159 degrees. So that means this angle is 159 degrees. That also means that this arc is 159 degrees. And guess what? I have another pair of vertical angles. These two are exactly the same. So if this one's 159, guess what? This one's 159 degrees as well. That I got so much from that one number. Okay, next thing. Measure of arc KL. K to L. Oh, look at that. It's this green piece that I just found. I already know it's 159 degrees. Next one. Measure of arc JKM. JKM. That means start at J, go through K, and end all the way at M. So you've got this yellow piece plus the green piece plus the yellow piece. So to find JKM, you've got two choices. You can add 21 plus 159 plus 21. Right, you're just working your way around its distance going around it. If I do that, I get 201 degrees. You can do that, or you can take 360, the whole thing, and subtract whatever's left over to give you your blue piece. So you can also do 360 minus this green piece that's left over is 159. And guess what? You're going to get the same answer. So either way should work out. All right, last one. Measure of arc MKL. MKL. That literally means do the whole circle except for this yellow piece right here. So you've got two choices again. You can add 159 plus 21 plus 159. Or you can take the whole thing as 360 and subtract this one piece. If you do that, you will get, oh no, I went the wrong way. I just realized that. Oh, Miss Damaso making mistakes. Look at her. I apologize, guys. Oh, went the wrong way. Went the wrong thing. Okay, here's why I went the wrong way. I have to go from M through K all the way back around to L. So I'm making a full circle, and then I'm adding to it another 21 degrees. Wait, no, I was doing the right thing. Oh my goodness, Miss Damaso, this is killing me. Oh, I'm so sorry. No, I did it right the first time. What am I doing? Oh, it's been a long day. I was right the first time. I'm sorry. I'm sorry, guys. I'm sorry. It should never be more than 360. I don't know what I'm thinking. Okay. So ignore that weird moment I just had. You're still going from M through K all the way to L. So it's almost a full circle, but you have to take away this little piece of 21. That was right the first time. I apologize for that. I'm having a moment today. Okay. Number 3. All right, first thing I see, before I even look over here, first thing I see is I've got an 87 degrees right here. This little piece is 87. That must mean that from T to U is also 87 degrees, right? I already have another piece over here is 72 degrees. I also see that I've got vertical angles right here. So if this is 72 degrees, this one is 72 degrees. Okay, and it looks like kind of all I've got right now because obviously these are not vertical angles, right? These are very different shapes, so those two are not vertical angles. So let's go through and let's answer some questions first. Okay, first one says, what is the measure of angle UXV? UXV. Oh my goodness, look at that. UXV. I already figured that one out. That little piece right there, since this arc is 72, that must mean that this angle inside is also 72 degrees. So both of those are exactly the same. Okay. Next one is the measure of arc ST. So now I want to figure out what this little piece right here is. Now, here's what I can do. I know if I were to add these three angles up right here, right, this purple, this orange, and this blue, I'd get half of a circle. So I would add those three up to get me to 180. So to figure that out, I can do 180 minus these two angles that are here, 87 and 72. Okay, so if I add those together, I'm really doing 180 minus 159 degrees, and I end up getting 21 degrees. So this little piece over here is 21 degrees. Okay, next one, measure of arc WV. WV. So I want to know what this whole arc is right here. Okay, now this whole arc, what I can do is, again, I can see two pieces that add up to be 180 degrees. So I can take 180 degrees and I can subtract this blue piece, and that will give me what's left over in the green. So WV, I'm going to do 180 minus 72. If I do that, I get 108 degrees. Okay, there's more ways than one to do it, so if you do it a different way, that's okay. All right, TW. Okay, TW is this to this. Okay, so to get TW, what I can do is I can add this pink piece plus this blue piece. So I'm going to do 21 plus 72. If I add them both together, I get 93 degrees. So my answer here, 93 degrees. All right, last one. Measure of arc TVW. Now, because it's 3 letters, I know that it's going to be a number bigger than 180. TVW, T to V through W. So it's the orange piece plus the blue piece plus the green piece. Okay, so to figure out TVW, I'm going to take the orange piece plus this blue piece plus the green piece, and I'm just going to add them all together, and when I do that, I get 267. You also could have just done 360, the whole circle, minus this piece and this piece, and you would have still gotten the same answer as me. So you really have a choice here. You can either do a lot of addition, you can do a lot of subtraction. It doesn't really matter how you do it. You're still going to get the same answers as me. Okay, so there's more than one way to do each one of these problems. All right, number 4. The measure of arc CD. So here's CD. I already know this right here is 90 degrees. That must mean that this arc right here is also 90 degrees. Okay, that was easy. All right, measure of arc FD. FD. Now I know this piece is 90. I also know that this piece has to be 90. Because 90 and 90 gets me a straight line. It gets me to 180. So this piece is also 90 degrees, which means, guess what? The piece that is vertical over here, this piece is also 90 degrees. Okay. So FD goes from here through E to here. This is FD. So to find FD, what I'm going to do is I'm going to add 34 and 90. And I get 124 degrees. 2 letters, so it means it's less than 180. It is, so I'm good. Next one is measure of arc DCF. DCF. So it's DCF all the way across. Whoop. Now, I know I'm going to have to add 90 and 90, but I don't know what this piece is right here. So the first thing I have to figure out is just what GF is. Now, to figure out GF, arc GF, I know that this piece plus this piece has to give me another 90-degree angle. So I'm going to take 90 and I'm going to subtract 34 from it. If I do that, I get 56 degrees. So this piece right here is 56 degrees. So now, to find the measure of the whole arc, DCF, I'm going to add D to C plus C to G plus G to F. So I'm going to add 90 plus 90 plus 56. And I get 236 degrees. Okay? Last one, GDF. Okay, so G to D all the way to F, so it's literally almost the whole thing, right? This is the yellow piece. It's It's almost the whole circle, but I have to not include this 56. So what I can do is I can either add 90 plus 90 plus 90 plus 34, or to make it easier for myself, I'm going to take the whole circle, 360, and subtract this piece 56 from it. And when I do that, I get 304 degrees. All right, got a couple more on the back. Okay, number 5. First thing I see is that there's a 90-degree angle there. I know that this piece right here is 19 degrees, T to S. Well, these are vertical angles, so this one also must be 19 degrees. I can figure out what this piece over here, P to Q, is because I know that this piece plus this piece gives me 90 degrees. So to find PQ, I'm going to do 90 minus 19. I'm going to get 71. So I know this one over here is 71 degrees. I know that if I were to add these 3 pieces, right, I would make a straight line, 180. Well, I know this is 90. That must mean this piece over here is also 90. So if you can get all the pieces on the outside first before you try to add everything up, your life is going to be like way simpler. Last thing I can do is right over here, SR. I can figure out this side because I know if I put this piece and this piece together, I should get 90 degrees right here, or excuse me, 180 degrees. It's a straight line. So just to find that one piece, what I can do is I can take 180 and I can subtract 19 from it. And I get 161 degrees. So now I know all of my arcs and all my pieces. Now it's really just going to be which pieces do I have to add together to get the answers over here. So PQ, let's see. P to Q, I figured it out, it's 71 degrees. S to R, I already figured out, it's 161 degrees. QRT, QR to T, I have to add I'm going to add together the 19, 161, and the 19. And when I do that, I get 199. Okay, so it's almost easier if I do everything first on the outside. PSR, PSR. So I'm going to add together 90 plus 19 plus 161. And I add those all together and I'm going to get 270. Great. And then the last one is P to S. P to S. So to find PS, I'm going to add together 90 plus 19. And so I get 109. Okay, there we go. We have now figured out a whole bunch of arc lengths. Now, for the next problems, we're going to find each value or measure. So we're going to do some algebra problems now that are going to go along with each one of these. Okay. For number 6, it asks me to find x. Okay, so in order to do that, I see that there's an x right here. I know that this piece from R to S is 15x minus 26. I also know that this piece right here is 26 degrees. If I put my orange and my yellow together, I make half of a circle, which is 180. So what I can do is I can say this plus this is going to give me 180. And then I'm just going to solve it like an algebra problem. So now this should be really simple for us. Well, negative 26 and positive 26 cancel each other out. I get 15x equals 180. Then I just get the x by itself. So I divide both sides by 15. I get x equals 12. And I'm done with that problem. Okay, number 7. Again, I want to figure out what x is equal to. Now, I know this piece right here, d to e, is 18x minus 2. I also know that this piece over here, d to h, is 15. Now, this gives me like a whole big chunk, but I don't have this piece over here to get me to 180. However, what I do know is that this angle right here, angle FIG, is vertical to the angle EIH, the whole thing. So I know if I add these two together, that should give me this whole angle, and this whole angle is 103 degrees. So I can say 18x minus 2 plus 15 equals 103. And then I'm just going to solve that equation. So I can reduce on the right. 15 minus 2 is 13. Now I subtract 13 on both sides. I get 18x equals 90. And then I divide by 18. I get x equals 5. And that's all that the question asked me for. So I'm done. All right, now you're going to notice in number 8 that not only do I ask you to find the x, but I'm also asking you to find some of the arc measures. So we're going to have to figure out what x is first, and then we're going to have to plug those in. Now, I am given this angle over here, B to C, and I'm given this, arc B to C, and then I'm also given arc A to D. I know that these two are vertical angles, so I know that these two must be equal to each other. Because they're equal, I'm going to write an equation that sets them equal to each other. And then I'm just going to solve the equation using some algebra. So the first thing I'm going to do is I'm going to subtract the 8x from both sides. Next thing I'm going to do is add 22 to both sides. Get 34 equals 2x. Then I divide both sides by 2. I get x equals 17. Now that is only one part of this problem. Because now I've got the 17, I need to plug it in. Now it doesn't matter which one I plug it into, so I'm going to plug it into this positive one over here. Okay, 8 times 17, and then I'm going to add 12. So this angle right here, this arc, is 148 degrees, which means this arc is also 148 degrees. Now, I can figure out what these two arcs are. These two are vertical, so they're going to be the same. I know if I add this plus this, I should get 180. So to figure out this piece over here, I'm going to do 180 minus 148, and I get 32. And that must mean this one's 32. Now that I have all those marks done, I'm going to solve each one of these arc lengths over here. So arc length AD, solved it, it's 148 degrees. Arc length CD, I solved it, it's 32 degrees. Major arc BDC, I can either add 32 plus 148 plus 32, or I can take the whole thing 360 and subtract what's left over. So I'm going to do BDC. I'm going to do 360 and subtract 148 because that's just a little bit easier for me to do. And I get 212 degrees. And I'm done. Okay, we're so close. 2 more questions. Number 9. Now, I'm given this piece JK is 5x plus 23. And I'm given this piece over here, KL, is 17x minus 41. Now, they're not vertical, but they are, if I put them together, gives me a diameter, which is 180 degrees. So I'm going to take these two, I'm going to add them together, and I'm going to set them equal to 180 degrees. Okay, so the first thing I'm going to do is I'm going to combine some like terms. So 5x and 17x is going to give me 23x. And then I'm going to combine 23 and negative 41. And if I do that, I get a negative 18. I'm going to add 18 to both sides. I get 23x equals 198. And then I divide by 23 on both sides. So I get x equals 9. Now, using that 9, I'm going to plug it in to both of these equations here. So 9 times 5 gives me 45, and 45 plus 23 is, this angle right here is 68 degrees. Great. That must mean this one over here is 180 minus 68, or you can take that number and plug it in. This piece over here is 112. Now I see vertical angles, so if this is 112, that means arc MJ is also 112. And I see that this arc JK is 68, that must mean its vertical angle is also 68. Now that I've got everything written, it's going to make my life way easier once I get over here. Okay, arc JK. JK, I already figured it out, 68 degrees. MJ, figured it out, it's 112 degrees. Major arc, so it should be greater than 180. LMK, I'll do it in a different color here. LMK, L, M, all the way to K. So go from from L through M, all the way to K. You can either add 68 plus 112 plus 68, or you can take the whole thing, 360, and subtract the piece that's left over that we're not using, and you get 248 degrees. Okay, last question. All right, so I'm going to mark some things that I see. I know that there's a 90-degree angle right here. Okay. I also am given that this arc is 8x. This arc is 21x minus 12. Now look, if I put this green piece and this blue piece together, right, I'm not making 180 degrees. I'm making something different. If I also add to it though, this piece over here, so if I were to add the green plus the blue plus the pink, I'd have almost 360, but I'd have 360 minus whatever this piece is. Well, this piece is a 90-degree angle. That means right here is also 90 degrees. So what I can do is take 360 and subtract this 90 degrees, and that should be what these three angles put together are going to be left over as. So if I do 360 minus 90, I get 270 degrees. So that means if I add the green plus the blue plus the pink, I should get 270 degrees. So that's my equation. The green plus the blue plus the pink equals 270 degrees. There's my equation. Now I'm just going to put some pieces together and solve it. So I can put all of my x's together. So that would give me 39x. And then I can put my constants together. So negative 12 and 9 is a negative 3. I add 3 to both sides. I get 39x equals 273. And then I divide by 39. I get x equals 7. Now, you already know the x. I would take that x and I would plug it in to every single one of those, okay? So if I plug in a 7 over here, 8 times 7 is going to give me, this is 56 degrees in the green. In the blue, if I plug it in, I get 21 times 7 minus 12, I get 135 degrees. And then the last one's in the pink. 10 times 7 is 70, plus 9 is 79 degrees. Okay, so now I can just take those numbers and I can fill out my little sheet over here on the right, the last part of the questions. Okay, so WX is this piece in blue. I already figured it out. It's 135 degrees. YW is going to be from Y to W, so it's got 90 plus 56. And that gives me 146. Okay. Y to X is just the purple piece. I already figured that out. It's 79 degrees. The last one is a major arc, so it should be greater than 180. It's VXW. Other way. V through X to W. So it's the whole thing except for this little piece. So you can either add these three together or you can take 360 and subtract the piece that's left over, which is 56 degrees, and you get 304 degrees. Okay, so now we are finished with our notes. You guys are going to go and try the homework questions that go along with it. They're called 10.1 Central Angles and Arc Measures homework. I apologize about that mistake that I did make there on that front side problem here with number 2. Make sure that you've got the right one written down. I apologize about that. So you're going to go into your homework section now. You're going to finish up your homework. If you have any questions, please feel free to send me a message. And that's it for our week 4 video 1 notes. Have a great day.